We're going to find a recursion formula for an arithmetic sequence. It says find the recursion formula for the sequence. So what is a recursion formula? Recursion formula is a formula in which each term is a function of the previous term. What does that mean? Well, it means that I need the previous term to get the current term. I need 2 to get 10. I need 10 to get 18. In other words, I can't just say, hey, go find the 100th term. I can't just skip all the way down and find a sub 100. I'd have to have a sub 99, and then I'd have to get to get that one, I'd have to have a sub 98, and I'd have to have, so recursion means we have to have the one in front of it to get that one. So let's see, how do we write a formula? It's actually easier than writing the general formula. So what we're basically, again, doing is we're going to figure out what has been added, what is being added or subtracted, because it says it's arithmetic, so we know there's a common difference. We just need to know what that common difference is. So this time it looks like they're adding 8. Adding 8. Now remember, they want a recursion formula, so we're not going to use a sub n equals a sub 1 plus n minus 1 times d. Okay? But we do know now that the common difference is d. Is 8, the common d. So what we're going to do is realize that to get any term, we need the previous term. So we're going to say to get any term, any a sub n, we need the previous term, which is, and the way that we call that out is a sub n minus 1. That's the term in front of this term here, right? So we get the previous term. Now, it's real simple. What are we going to do? What are they doing each time? They're adding 8. That's it. That's all you have to do. Put whatever they're doing to on the end of it, and we have it. Now, we do have to say what the first term is. So we have to say, given that a sub 1 is 2, there's that, and then we have to say this, for n greater than or equal to 2, right? Because we're going to start with 2 here because we already have 1. All right, so there's the answer right there. Let's take a look at one more. Now, you notice it says for the arithmetic sequence. So this time we're not trying to figure out if it's arithmetic or not. We're just trying to write a recursion formula for it. All right, recursion formula means I need the previous one to be able to find the next one. So I'm going to say a sub n is equal to a sub n minus 1, which is the previous one. Now, what is my common difference? I have no idea. Well, how could I figure out the common difference when these aren't just as, it's not as easy to just see the common difference here. What I'm going to do is something that I could have done back here. I could have taken 10 and subtracted 2, or taken 18 and subtracted 10, right? To get the plus 8, the plus 8. So what I'm going to do here is the same idea. I'm going to take the 5/6 and I'm going to subtract a third from it and see what I get. Well, that just means I need a common denominator, which means I'm going to have 2/6. So 5/6 take away 2/6 is 3/6, which is 1/2. So I think my common difference is adding a half, right? Adding a half. It's positive, so it's adding. So let's see. If I take 5/6, then I add a half to it. Let's see if we get the 4/3 that is right there. So we're going to go ahead and go times 3 times 3. And we get 3/6. And I get 8/6. And 8/6 is indeed 4/3. So it is true. The common difference is a half. So what am I going to do with my recursion formula? I'm going to write plus 1/2. Okay, now let's finish it up. For what? For n greater than, for n greater than or equal to 2. And now I have to give the first one, right? A sub 1 is a third, so we know we have to have a starting point. And then starting with the 2, I'm going to find any other term as long as I go in order. All right, thanks for watching. Hope it was helpful.